everyone, and Salam Sejahtera for those who are watching this video. Our group are here to present our group project 2, SPSS and Smartpls analysis. My name is Dan Sokin with matrix number BE34403. And I will present output question 1, demographic profile. As shown in the table, out of 225 respondents, the majority, 99 people, or 44%, attended to seek travel promotions. This was followed by 79 respondents with 35.1% who attended to plan their next trip, and 38 respondents, 16.9% for planning their first trip, and only 9 people, 4% had other proposals. Next is frequent traveler. The results shows that 152 out of 225 respondents, or 67.6%, identify as frequent travelers, while 72 respondents with 32% said no. There was also one missing response representing 0.4%. For the third demographic question, we asked how often respondents travel in a year. The highest percentage, 98 respondents or 43.6%, travel 3 to 4 times a year. This was followed by 93 respondents, representing 41.3%, who travel less than 2 times a year. Meanwhile, 22 people with 9.8% travel 5 to 6 times, and 12 respondents, representing 5.3%, travel 7 to 8 times a year. Lastly, for the fourth question, we asked about the purpose of traveling. The result is very clear. 100% of respondents selected vacation as their reason of traveling. That's all from me. I will pass it to the next presenter. Thank you.
My name is Amira and I'm going to explain question 2. So, to perform a factor analysis using SPSS on travel motivation construct, the first step is to open SPSS and load the data management SPV file. Step 2, press Analyze, Dimension Reduction, and Factor. Next, for step 3, a pop-up window will show after you do step 2. Then move mode 1 until mode 13 into the variable box. Step 4, click descriptive, then check the initial solution, anti-image, NKMO, and Butler's test of sphericity, then click continue. For step 5, click extraction, then the method choose principal components, then check correlation matrix, pre-plot, then choose fixed number of factor and the factors to extract set to number 2, then click continue. For step 6, click rotation and choose ProMake as method, check rotated solution and loading plots, then click continue. For step 7, click option, check sorted by size and suppress small coefficient with value which is 0.4, then click continue. Then final step, which is step 8, click OK to run the factor analysis. The Kaiser-Meyer-Olkin KMO measure of sampling adequacy was 0.932, indicating excellent suitability of the data for factor analysis. Butler's test of sphericity was significant, which is P less than 0.001, suggesting sufficient correlation among items. Principal component analysis (PCA) with ProMax rotation was performed, with 2 components were extracted based on fixed criteria. These 2 components accounted for 64.17% of the total variance, satisfying the minimum threshold for factor retention in social science research.
Hi, I am Angela Siti Charles. I will be presenting the result from our principal component analysis, which use a ProMake rotation. This rotation method is used because we found that our factors are correlated. First, let's look at the screen plot. As you can see, that plot clearly show an elbow after the second component. This indicated that 2 components are the most significant to extra from our data. Eigenvalue, where both components have eigenvalue greater than 1. Set on the variables, these pull factor components seem to represent a desire for novelty and exploration. It reflects a motivation to seek out new experience. Again, knowledge and embark on adventurous journeys. Moving on the second component, which we named the push factor, this component is strongly influenced by variables such as Mode 1 to experience a different culture, Mode 2 to explore local craft and handicraft. This one has a very strong loadings. Mode 3, to experience local cuisine and new food. Mode 4, opportunity to experience people from different ethnic backgrounds. Mode 5, meeting interesting and friendly local people. Mode 7, opportunity to see and experience unique native people. Therefore, this boost factor component appear to represent motivation driven by desire for culture and local immersion. It's scientific and internal urgent for tourists to deeply reach the local culture, people, and unique heritage of.
In the Smartpls analysis, the auto-loading is used to check how each item relates to its construct. Auto-loading tells us if the question or indicator are good at measuring what they're supposed to measure. The standard rule is that the value should be above 0.70. In this study, the construct extreme event was divided into 3 parts, which is act of terrors, airline disaster, and natural calamity. All the items under these 3 shows a strong auto-loading values, which is for the act of terrors, it's between 0.87 and 0.94, and for the airline disaster, it's between 0.85 and 0.92, while for the natural calamity, it's between 0.88 and 0.93. Since all the values are above 0.70, it shows that each item fits well with its construct and is reliable. So we can say that the measurement model is strong and the items we use are good, and the indicator of the 3 sub-construct of the extreme events.
Hello, my name is Ara Dominic. My metric number is BB34403. In this section of presentation, I will discuss the cross-loading results which were conducted to assess the discriminant validity of the construct used in our study. As we can see in the table, cross-loading analysis was applied to examine whether each item loads higher on its assigned construct than on any other construct. This is a critical step in verifying the discriminant validity within a reflective measurement model, particularly in structural equation modeling, which is SEM, using tools like Smartpls. Let me begin by briefly describing what each construct in this table represents, which is act of terrors, airline disaster, destination image, extreme events, natural calamity, pull motivation, travel motivation, and the last one, push motivation. Each row in the table represents an item or indicator such as DES1 to DES5 for destination image and extreme 1 to extreme 10 for extreme events. Now let's examine the discriminant validity through the loadings. 1 item to construct relationship. Each item should have the highest loading value with its respective construct compared to all other constructs. For example, DES1 loads 0.805 on destination image, which is higher than its loading on other constructs such as act of terrors, which is 0.102, airline disaster, which is 0.140, and extreme events, which is 0.121. This support the DES1 is a valid indicator of destination image. Similarity, extreme 5 show a loading of 0.886 on extreme events, while its loading on other construct remains significantly lower, confirming its strong contribution to the intent latent variable. Number 2, strong convergent validity. Most indicators show loadings above 0.7 on their respective construct. For example, extreme 9 has a high loading of 0.954 in natural calamity, which is MOT 9 has a loading of 0.786 on push motivation. This indicates that the items are well correlated with their intent latent variable, confirming convergent validity. Number 3, which is weak cross-loading. We also observe the cross-loading are relatively low, which further support discriminant validity. For instance, MOT 5 load only 0.057 on natural calamity and negative 0.002 on act of terrors compared to 0.810 on push motivation. Extreme 8 load only 0.147 on pull motivation but 0.953 on natural calamity. This shows that each construct is unquickly measured by its item and not confused with others. So there are few borderline cases where loading are close to each other. For instance, extreme 10 loads 0.837 on extreme event and 0.861 on natural calamity, suggesting on potential overlap or conceptually similarity. However, both of crisis-related factor and some overlap is theoretically acceptable as long as the primary loading is still higher. So for the conclusion, the cross-loading result demonstrates strong discriminant validity among the construct in our model. Each item loads highest on its assigned latent construct, and cross-loading on non-related construct remain low. This supports the construct validity and reliability of our measurement model.
Next, I will present the finding related to the reliability and validity of the construct. As seen in the table, all constructs show strong internal consistency, which is Cronbach alpha values are all above 0.80. The highest alpha is extreme event with 0.956, followed by the airline disaster and act of terrors with both above 0.91. Looking at the composite reliability, RHOA, all values are also above at the 0.80 threshold, ranging from 0.812 to 0.956. This further confirms that each construct has consistent measurement indicators. In the terms of composite reliability, RHOC, all constructs again show good reliability, with extreme event recording the highest value at 0.962. Lastly, the average variance extracted, the most construct exceed the 0.50 benchmark, confirming convergent validity. Construct like act of terrors 0.856, airline disaster 0.806, and travel motivation 0.841 show particularly strong average scores. Overall, this result provides strong evidence of construct reliability and validity, supporting the quality of the measurement model.
Next, I will present the result of the discriminant validity assessment. This analysis was done using the heterothread monothread method, commonly known as HDMT. What is discriminant validity? This discriminant validity is used to test whether the constructs in our model are truly different from each other. In other words, it helps us to confirm that each concept measures a unique idea and is not too similar or overlapping with other concepts. The HDMT ratio is one of the most reliable methods to assess this. It compares the correlation between different constructs. So according to common guidelines, if the HDMT value is below 0.85 or 0.90, it means the constructs are different enough and means this is a good sign. But if the HDMT value is above 0.90, it shows that the construct may be too similar and this can be a problem for the model. So some important results from the HDMT metric based on our data such as act of terror and airline disaster, the HDMT value here is 0.909. This is slightly above the 0.90 threshold, which means there might be a problem in the discussing these two concepts clearly. Extreme event and airline disaster, the HDMT value is 1.035, which is quite high. This suggests a strong overlap, meaning that two constructs may not be clearly separate in the respondent's mind. Extreme event and natural calamity, the HDMT value is 0.962, again higher than the accept limit. This shows that these two risk-related constructs may have been viewed as too similar. Travel motivation and pull, the HDMT value is 1.118. Travel motivation and push, the HDMT value is 1.144. Both of these are much higher than 0.90, which is a serious concern. It suggests that respondents could not clearly separate between general travel motivation and the specific push or pull factor. This construct might need to be revised or measured differently in the future. So, example of good discriminant validity. On positive note, there are construct pair that show very low HDMT value, which is mean the construct are well separate. For example, destination image and act of terror, the HDMT value 0.116. Destination image and natural calamity, the HDMT value is 0.116. This low value show that these constructs are clearly different and discriminant validity is achieved here. Overall, some construct pairs in the model show strong discriminant validity, meaning they are clearly different and well defined. However, other pairs, especially those involving travel motivation, push and pull factor, and extreme event, show HDMT value that are too high. This suggests that this construct may be overlapping and may need to reconsider how to define and measure in the future studies. Understanding and fixing this issue is important before move on to test the structural model of the research.
Assalamualaikum, I am Siti Nurfatima binti Sanuddin, metric number PP221100609. The last part is the PLSM's Malaysia Tourist Vacation. In this diagram, we need to think of PLSM as two link steps. The first one is measurement model, which is outer model, and the structural model, which is inner model. The first one is measurement model. The purpose is to check that each survey question, for example, DS1, Extreme 3, MOT5, etc., really belongs to the factor that we think it does. Destination image, extreme events, travel motivation, and etc. How we know it works? The outer loadings, the number of the arrow in this diagram, from each latent factor to each item. Anything above 0.70 is considered as strong, while 0.50 until 0.70 is acceptable only if they have a good reason. In our diagram, almost every loading clocks in at 0.75 until 0.95. That means DES1 until DES5 hang together nicely under destination image, Extreme 1 until Extreme 9 under extreme events, MOT1 until MOT9, or the two higher in this diagram, which is motivation 1 and motivation 2 under travel motivation, and etc. Only a couple like DES3, 0.64, or MOT2, 0.53 dip just under 0.70. So we might flag those for possible revision, but overall our measurement model is solid. The second one is structural model, which is inner model. The purpose is to estimate the strength of the error between construct, for example, who influence whom by how much, and see how well our predict explain each outcome. Path coefficient, or the betas, push travel motivation 0.96, pull travel motivation 0.53. You can see in this our diagram, for example, risk from extreme events, natural calamity, airline disaster, and acts of terror fits into perceived. The interpretation, a path coefficient 0.96 is massive. It means push factor, which is the internal drive such as escaping routine, rest and relaxation, almost perfectly predict the strength of someone's travel motivation in our sample. A coefficient of 0.53 is still large. Pull factor, which is destination, attraction, scenery, hospitality, also play a big role, but about half as strong as push. The next one is the R-squared. How much of the variation in endogenous, which is dependent, construct is explained by its predictors. In this diagram, you can see that a small 0.99 next to the travel motivation circle. That means 49.9% of the difference in tourist motivation scores are explained by our push and pull factor and other incoming error in the model. In PLS terms, R-squared, which is 0.50, is considered as moderate, so we have captured about half the story of what drives Malaysia students to vacation. Thus, the measurement model is reliable and valid. Most items load strongly, which is more than 0.70. Composite reliabilities are more than 0.80 and AVs more than 0.50. The next one is the structural model, shows very strong effects of push factor and overall travel motivation, beta 0.96, and substantial but smaller contribution from pull factor, beta 0.53. To sum up, Smartpls confirm our survey hangs together as intended and then quantify just how powerful those push and pull motivation are in shaping Malaysian student vacation intentions. That's all from me, thank you.